Welcome to the project demonstration of energy meter monitoring with voice alerting system. So here we are going to monitor the two parameters. One is kWh, nothing but kilowatt hour, and next kW, so kilowatt. So nothing but how much of load was connected on the energy meter, that will be monitored in a kilowatt readings, and also how much of energy consumed by this loads till per hour, that will be calculated and displayed on the LCD in kWh. So these two readings will be displayed on the LCD screen, and we have set the limit for the kilowatts. So whenever the load crosses the connected load crosses the 100 watts, then automatically a voice alert will be announced from this APR33A3 voice module. So to indicate the user about the high load was connected to the energy meter. And after a certain duration of time, so whenever the energy reading, kWh reading crosses 0.054 kWh, then it will alert the user about you have consumed the more energy, then take care of the remaining duration. So these two announcements will be done with the help of PIC microcontroller. So we have interfaced this energy meter to calculate the energy readings to the microcontroller at A4 pin through this PC817 optocoupler. So in order to calculate the load and kW and kWh readings, we need to get the pulse input from the energy meter LED. This LED will show the status of the load connected on this energy meter. So whenever the blinking rate crosses the 3200 blinks, then it will consider as a 1 kilowatt hour. Means if it blinks 3200 blinks, then that's equal to 1 kilowatt hour. Means 1 kilowatt of energy consumed by the load in the duration. And the next, if you want to calculate the load, then if the blinking rate is 1 second per second, the LED blinks, then it's indicated as 1000 watt of load was connected. So this is the calculation part. I'm repeating that. If the blinking rate of this LED is 1 second duration, then the load was 1000 watts, means 1 kilowatt only. And if the blinking rate is 3200 blinks completes, number of blinkings completes, then it is considered as a 1 kilowatt hour. So based on this calculation, our system will calculate the kilowatt hour and kilowatt by getting this blinking on the A4 pin. So we have interfaced through the PC817, so not the directly, though LED taking DC power supply. So if is there any short circuit occurred inside this energy meter, the direct current of the AC will be given to the microcontroller, so it may get damaged. In order to protect our main motherboard, so we place the PC817 is an optocoupler in between the LED and our microcontroller. So in this, it is a 4-pin IC. In this, the input 2 pins are connected to LED inside this, and output 2 pins are connected to a phototransistor. Whenever this light blinks, the same current will given to the LED inside this PC817, and that LED will blinks and that will be fall on the phototransistor. So that pulse will be given to the microcontroller. So if is there any high current generated, high current short circuit happened in this energy meter, only this IC may get damaged, so that we can just replace the small IC so that our main motherboard will be safe. So for that purpose, we are making use of this PC817 optocoupler. So based on this blinking from this one, our microcontroller will calculate that. So we have coded with the embedded C language. So after that, the status will be displayed on the LCD screen along with kWh and kW readings. So whenever the threshold value crosses, whether it is a kWh or a kW, then voice announcement will be done from this APR33A3 voice module. So here APR33A3 voice module means it's an audio playback recorder. Predefinedly, we need to record some voices inside that, and based on the input from our microcontroller, it will announce the respective voices. So we have interfaced that at C0 to C3 pins, LCD pin number B2 to B7, and the whole system getting power supply from this regulated power supply board. So which will take 230 volts AC input. We are providing parallelly to the energy meter, the output of the energy meter given to the bulb directly, and to this extra load through this switch. And this regulated power supply board consists of 4 stages. One is the transformation, and the next rectification, and next filtration, and next regulation. So transformation means it will step down the 230 volts AC to 12 volts AC, and rectification will convert the AC to pulsating DC, and the filter will remove the pulses, so we will get the pure DC of 12 volts. And we need 5 volts power supply to the input and output modules. So for that purpose, we are making use of 7805 regulator, which will take 12 volts DC input and provide us the 5 volts constant DC output. So once we provide the 5 volts DC to that, so it start reading input from this PC817 optocoupler. Whenever the LED blinks, it will blinks here also, so that the blinking rate will be converted into kWh and kW. So then after, when the threshold value crosses, so it will provide the voice output signals. And on this motherboard, so there are the three major components. One is the crystal oscillator, another is a microcontroller, and a reset switch to restart the microcontroller. So here the crystal oscillator purpose is which will provide the 20 megahertz of clock frequency to the microcontroller. So the purpose of these oscillations are, so we have provided the instructions to get reading input from the inputs and control the outputs. So these instructions need to be executed based on the clock pulses. Per instruction, controller will execute one clock pulse needed. So per instruction, so when we provide the 20 mega clock pulse per second, controller can execute 20 mega instructions per second. So let us see the demonstration. So when we switch on the kits, we need to wait for 2 to 3 readings to be settled down by the microcontroller for accurate readings.
Energy meter monitoring and alerting system.
Right. Initially, it will announce the welcome message, and then after it will keep on calculation. For faster readings, you can on the 2 loads at a time. So when we add the more load, then the blinking rate will be more, so the calculation will be the fast, so we'll get the fast readings. So as of now, we have connected the 100 watts and 60 watts, so it's showing the 163 kilowatts. It's 163 watts. So if I off that, so it will be settled down slowly. So 100 watts again, it will goes to the normal loading again. So we need to neglect 2 to 3 readings for better accurate final values. So when we connect the low wattage load on the energy meter, so it will take more time. When we add the more wattage load to the energy meter, it will take the less time to calculations, as it's directly proportional to the blinking rate. The calculation part was right now it is 62 watts. Okay. So whenever the high wattage was detected here, so it will wait for another extra reading also, because for malfunctioning,
Alert,
right.
high load, please check. Alert, high load, please check.
So the voice will be keep on announce till the load was under control, and we have set for time limit also. Once the time was complete, then automatically high load consumption message will be announced. So it will take maximum of 1.5 minutes.
Alert, high load, please check. Alert, high load, please check. Alert, high load, please check. Alert, high energy consumption, please check.
Right, alert, high energy consumption was announced now. So it will be keep on announced for every so-called same duration. So consider for every 10 reading calculations, we are announcing the high energy consumption
Alert, high load,
message.
please check.